All right, so the title for this explainer is Verifying the Vibe. And that little word, vibe, it's really at the center of a huge security problem we're all facing. How on earth do we secure this absolute flood of code that's being generated by AI?
I mean, think about it. What if the biggest productivity boost your team has ever seen is also its single greatest security risk? That's the conflict, right? Every single development team is grappling with this. These AI assistants, they promise incredible speed, but they're also introducing these brand new system-wide risks that, honestly, we're just starting to understand. So let's break that down. And more importantly, let's talk about what we can actually do about it.
So the term that's kind of bubbled up for this is vibe coding. Yeah, vibe coding. Instead of working from these super precise formal specifications, developers are, well, they're having a conversation with an AI. They're building software based on intuition, just a vibe. And let me tell you, this is a total revolution in how software gets built.
And this right here, this gets to the absolute core of the danger. For decades, everything we've done in software engineering, all the best practices, were designed to get rid of ambiguity, to make things crystal clear. Vibe coding? It does the exact opposite. It throws ambiguity back into the system on a massive scale. Think of the chain. You start with an imprecise human vibe, you translate that into imprecise language, and then a non-deterministic AI, which by the way means it can give you different answers every time you ask, has to interpret it. It's just ambiguity piled on top of more ambiguity.
Okay, so let's start with the most common problem. We're talking about the unintentional flaws, the ones that aren't malicious but are just systemic. These are the bugs and vulnerabilities that AI assistants are just pumping into our code bases day in and day out.
Get ready for this number. A major study from Veracode, it found that almost half, 45% of all code generated by AI has security flaws. Just let that number sink in for a second. What that means is, if you're not doing incredibly rigorous checks, you are almost certainly pushing vulnerable code into your applications. It's practically a coin flip.
But here's the thing. This risk isn't spread out evenly. Not at all. That same study found that when AI generates Java code, it's insecure a shocking 70% of the time. 70! Now, Python and JavaScript, they do a bit better, but their failure rates are still hanging around 40%. So yeah, the language your team decides to use, it has a direct impact on your level of risk. So why is this even happening? Well, the AI isn't learning security principles in the way you and I do. It's basically just a brilliant pattern matcher. It's been trained on this enormous corpus of public code from places like GitHub, and a lot of that code is flawed. So when a developer gives it a naive prompt, just asking for a function without saying and make it secure, the AI just gives back the most statistically likely answer. And guess what? That is very, very often the most insecure one.
Okay, as scary as all those unintentional bugs are, the threat gets a whole lot darker. Now we're talking about intentional, malicious attacks. This is where the bad guys aren't just taking advantage of the AI's mistakes, they're actually weaponizing the AI itself.
Generally speaking, these attacks on the models themselves fall into two main camps. You've got white box attacks, where the attacker has the full blueprints. They know everything about the model's architecture. But what's really chilling is the black box scenario. That's where the attacker can only poke at it from the outside, just sending prompts and seeing what comes out. And even then, they are still finding and exploiting major weaknesses.
And that brings us to this terrifyingly clever attack called indirect prompt injection. See, this isn't about tricking the developer. It's about tricking their AI assistant. The malicious part, the command, it's not in the prompt that you type in. No, it's hidden somewhere else. It's buried in a file that you ask the AI to look at, maybe in your project's documentation, or hiding in a simple CSV file.
And the attackers are getting incredibly sophisticated with this stuff. Take the rules file backdoor attack. They'll hide malicious commands inside files you already trust, like a config file, using invisible characters that a human reviewer would never, ever see. Then they get around the AI safety filters by telling it a little story, framing the malicious command as something harmless. And here's the kicker. They literally tell the AI to hide what it's doing to delete its tracks from the chat history. It makes the whole thing almost impossible to detect.
But the attacks aren't just about hiding malicious code. Attackers are also exploiting the AI's weird tendency to, well, just make things up. It's called package hallucination. The best analogy is asking a librarian for a book and they just confidently invent a title and an author for a book that was never written. The AI does the same thing. It'll generate perfectly good-looking code that relies on a software package it just completely made up.
And this, of course, creates the perfect setup for a nasty attack called slopsquatting. It's so simple, it's brilliant. Attackers just ask the LLMs what package names they tend to hallucinate. Then, they go and register those names on public repositories like PyPy or NPM and upload malware. So when a developer trusts the AI's suggestion, goes to install this package, they're actually installing the attacker's malicious code. The AI assistant basically becomes an unwitting accomplice in a major supply chain attack.
And don't think this is some rare one-in-a-million glitch. Nope. Studies are showing that the top commercial models are hallucinating these packages over 5% of the time. And for open-source models, that number just skyrockets to almost 22%. This has opened up a huge, brand new, and very fertile territory for supply chain attacks.
So, how in the world do we defend against all of this? The answer isn't some magic bullet, some single tool you can buy. It's a multi-layered strategy. It's about shifting our entire focus away from just reviewing code to truly verifying what it's supposed to do and how it actually behaves.
We absolutely have to layer our defenses. Your traditional tools, things like static analysis or SAST and dynamic analysis or DAST, they're still essential. They're great at finding known vulnerability patterns. But here's the crucial part. They can't tell you if the code is actually doing what you wanted it to do. They can't read your mind. And that's where something called formal verification comes in. This is different. It uses math to prove that the code behaves exactly, and I mean exactly, as you specified. This all leads to what really should be the new gold standard workflow. So instead of just vibe coding, your team needs to adopt a specify, generate, proof cycle. It's a loop. First, you specify. You create a precise, even mathematical, definition of what you want. Then you let the AI generate the code to meet that spec. And finally, you prove it. You use formal verification to prove the code does exactly what you specified. It's this powerful feedback loop that gets rid of those risky vibes and replaces them with cold, hard mathematical proof.
You know, this whole new world of AI-driven development, it's not just about getting new tools. It really demands a fundamental change in how we think about the role of the developer and even about the nature of cybersecurity itself. So why is just reviewing AI-generated code so ineffective? It comes down to our own brains, to our cognitive biases. We all have automation bias, which is that tendency to just blindly trust what the AI spits out. We have confirmation bias, where we look for evidence that the code is right instead of actively trying to find what's wrong with it. And then there's anchoring bias, where we get stuck on the very first solution the AI gives us, and we don't even think about better, more secure ways to do it. What this all means is that the job of a developer has to change. It's already changing. They're not just authors of code anymore, writing line by line. They need to become strategic AI overseers. They need to be experts in high-level design and crafting incredibly precise prompts, and in using these advanced tools to verify and really manage their AI partners.
And all of this leads us to a new reality, a constant, continuous arms race. The attackers, they're using AI to craft malware and find vulnerabilities faster than ever before. So in response, the defenders are also using AI for things like detecting anomalies, analyzing malware, and even building systems that can heal themselves. This back and forth, this cycle of AI-powered offense and AI-powered defense, that is the new frontier of cybersecurity.
So let's wrap this up. What are the key takeaways here? What do you need to do? First, embrace a zero-trust mindset. Trust nothing that comes from an AI without verification. Second, you have to mandate that specify, generate, prove workflow, especially for your most critical systems. Third, invest in that layered verification toolkit we talked about, SAST, DAST, and formal methods. You need all of them. Fourth, start redefining your engineering roles to focus on that strategic AI oversight. And finally, build your governance policies on solid established frameworks from organizations like NIST and OWASP.
And that really leaves us with one last big question, a provocative one. In this new era of AI, the most important thing you can ask your organization is this: is your team just reviewing code, or are you actually verifying intent? Are you just checking what the AI wrote, or are you proving that it does what you actually meant for it to do? Because honestly, the security of your entire system, it hangs on that answer.